In this video, we'll be looking at the division properties of exponents on 7.2. So our essential question will be, how do I use the division properties of exponents? How do I use the division properties of exponents? So, like the last lesson, when we were multiplying similar bases, we would add the exponents. So if I'm dividing similar bases, what do you think will happen with the exponents? We will subtract them. So when I have a to the x over a to the y, that is equal to a to the x minus y. One quick note to remember, this will be helpful for us, is don't forget about hidden ones. And another note we'll need is whenever you're dealing with these, simplify the coefficients like a fraction. Okay, so let's start and use these hints to help us along the way. So I have x to the fifth over x cubed. No hidden ones needed, no coefficients to simplify. So I'll just go ahead and subtract my exponents. So I go 5 minus 3, and this will be x to the 5 minus 3, which is equal to x squared. Number 2, it's the same process. No hidden ones, no coefficients to simplify, so I will subtract my exponents. So I'll have x to the negative 5 minus 3, which is equal to x to the negative 8. Typically, we don't leave things with negative exponents, so we'll go ahead and move that, and it's 1 over x to the 8. So we're just subtracting these exponents. Similar basis, subtract the exponents. So number 3 will go equals y to the negative 4 minus 3, y to the negative 4 minus a negative 3, and whenever we do minus a negative, we end up adding, so that's going to equal y to the negative 1. Don't want that negative exponent, so we'll move it, and it becomes 1 over y, or 1 over y to the 1. Either one's acceptable. Okay. So that's just subtracting the exponents. Let's dive in a little deeper. Remember, we want to simplify coefficients as if they are fractions. So I have 8 over 2. That simplifies to 4. And then I have m to the 7 minus 3. So that would equal 4m to the 4th. Number 5, I'm going to simplify my fractions. Then we'll subtract our exponents. So I have 9 over 6. That would simplify to 3 over 2. And then this is how I like to do these. Whenever we're subtracting, whatever our result is goes in the numerator, positive or negative exponent, and then we'll move it around as necessary. So I'll have 0 minus 5, w to the 0 minus 5, and x to the 6 minus 6. So that's going to be equal to 3 with a w to the negative 5, x to the 0 over 2. Now the w to the negative 5 moves down, and the x to the 0 becomes 1, so it essentially kind of cancels out. So we have 3 over 2w to the 5, because that one kind of cancels out since it just becomes 1. So if you would, go ahead and pause right here. Try number 6 on your own. Remember, simplify the fraction part first, then do your subtraction. Don't forget about any hidden ones that we might need. So subtract, hidden 1 on the A. So we subtract our exponents, subtract, and then anytime you do the subtraction, your result ends up in the numerator, and then you move it around as needed. The c to the 4th, I mean, it doesn't have anything to subtract with, so it will stay where it's located. There's nothing happening to it, so it just ends up staying in the denominator. So go ahead and pause right here and try this one on your own. So hopefully you took the time to try this one on your own. First we'll simplify that fraction, so that becomes negative 4 over 3. I'll do my a's. A to the 4 and a to the 1 will be a to the 3. 4 minus 1 is 3. B cubed over b squared, that's 3 minus 2, so that becomes b to the 1. Don't have to write the 1, so I'm not going to write the 1. And nothing happened with the c to the 4th, so I will leave it where it's located, c to the 4th. Now, are there any negative exponents where I need to move them around? There's not. A is positive, positive 3, B is a positive 1 that's hidden, and C has a positive 4, so we'll leave everything in its place. Okay, so now if we have a power of a quotient property, it's very similar to that power of a power property, where I'm simply distributing the exponent to every exponent in the numerator and in the denominator. So what this would look like is if we have a to the x over b to the y raised to the z, that's the same as a to the zx, z times x, over b to the zy. We're multiplying those together. A to the z times x over b to the z times y. So it's kind of like a distributive property where the z gets multiplied by the x and by the y. Okay, so let's see if we can make that happen. So I'm going to take this 3 and I'm just going to multiply it by all the exponents. So we end up with x to the 12 over y to the 6. And we're done. That's all we have to do. Now number 2, this is where we might need our hidden 1, so we know what we're multiplying by. 2 times 1, 2 times 1. So I'm going to distribute this 2 to the 1s, so I end up with 5 squared over 8 squared. We'll simplify that and get 25 over 64. Number 3, it's helpful to write in our hidden 1s. And then we'll do our distributing. Negative 4 goes to each 1. So we end up with z to the negative 4th over 4 to the negative 4th. Now since we have negative exponents, we've got to do some moving. Z's in the numerator with the negative, so we're going to move this z and its 4 down, and 4 with its negative will move up. So this is really equal to 4 to the 4th over z to the 4th. Now we'll simplify our numbers. 4 to the 4th will equal 256, I believe. 256, and the z to the 4th stays the z to the 4th, and then we're done with the problem. Now let's move on to number 4. Same idea. I'm going to write in my hidden 1s. These are starting to get a little more complicated as we go. Now I'm distributing this 5 to every single exponent. So it's going to be distributed 1, 2, 3, 4 times. Every exponent gets that. So I have 5 to the 5, m to the negative 10 over 10 to the 5 and n to the 30. Just multiplying that 5 by each one of those exponents. First thing I like to deal with is my negative exponents. I only have one negative exponent that's on this m, so the m, since it's in the numerator, it will move down to the denominator. So now I have 5 to the 5 over 10 to the 5 times m to the 10th times n to the 30th. And then we'll simplify our numbers. 5 to the 5th is 5 times 5 times 5 times 5 times 5. So that's going to be 3,125 over 10 to the 5th means we just have 5 zeros. So it's 1, 1, 2, 3, 4, 5. 100,000 times m to the 10th, n to the 30th. So that's one way of doing these. And an even easier way is sometimes to simplify what's in the parentheses first, then distribute. So for example, so this is why we have these two different examples. This is where we don't simplify first, and here we'll simplify first. If I have 9 over 3, that becomes 3. And then a to the 8th over a squared becomes a to the 6th, subtracting. And we raise that to the 4th. Then we write in our hidden ones. Now we distribute that 4. And we end up with 3 to the 4th times a to the 24th, which is equal to 81 a to the 24th. So it seems like it would be better if you here do this like what we did here. The main part of this problem right here was simplify first. If we simplify what's in the parentheses first, using that order of operations, do whatever we can on the inside, then it makes our math a little bit easier later down the road. So go ahead, pause right here, see if you can do number 6 on your own. Try simplifying on the inside first, and I think life will be a lot easier. So let's try that. So pause here and try. Okay, so if we took a chance on this one, let's see what we can do here. So first thing we'll do is simplify first. I have 15 over 3, that becomes a 5. And then I have x to the 8th over x to the 8th, 8 minus 8 is 0. So those kind of cancel each other out because that'll become 1. So those cancel each other out. And the y to the 4th just stays y to the 4th. And then we have our exponent of 3. Let's write in our hidden 1. And now we can distribute our exponent on the outside. And we get 5 to the 3rd power, y to the 12th. And we'll simplify that, and 5 to the 3rd power is 125. And then we have our y to the 12th. So I always recommend simplifying first. It makes life a lot easier. So with that said, thank you very much for watching this video. That is how we will use the division properties of exponents to solve these exponential, or simplify these exponential expressions. Thank you, and have a great rest of your day.